Okay, so this lecture is on the heap sort. The heap sort are basically trying to build a heap tree. So it uses a method called, it's known as the heapifying method. And I can generate either a max heap or a min heap according to this. So here are the numbers I want to sort. First I'm going to take 15, now I'm going to take 20 to the left. Now since it's a max heap, the root node has to be greater than the child's node. So in this case, 20 is greater than 15, so I'm going to swap these two. When I swap them, I come up with 20 and 15. Okay? So now I'm going to add 7. So I have 20, I have 15 on the left child, and 7. This meets the heap's conditions, so that's not a problem. Now I'm going to add a 9. So in this case, I have 20, I have 15, I have 7. Now if I do a 9 here, does this meet the heap's standard? So if it does meet the heap standard, then this is fine. Okay, so I added, that means that every root, every parent's node is greater than the left or right child. So 15 is greater, 20 is greater, so this is no problem. Now I'm going to add 30. So when I add 30, see this is my existing 7 node here. So when I add 30, I put 30 right here. Okay, now here's an issue. So 30 is greater than 15. I'm going to swap these two. So I'm going to swap 15. So if I put 30 here, and this becomes 9, 15, 20, and 7. Okay, still that doesn't meet the heap structure. So I would have to swap these two. Okay, so then I'm going to have 30 at the root, the parent's node, and that's going to be 20. And this is going to be 9, this is 15, and this is 7. Now, this is known as a max heap. What is a max heap? So that means the parent's node is greater than either the left or the right child. Now, we are going to do the sort, the heap sort. We always going to take the root. So if I take the root, I'm going to print 30. See, that's 30. I'm going to take the bottom level here, which are known as the leaves. I'm going to swap it up here. So in this case, I'm going to put 15 up here. That's a 20. And this is 7. And that's a 9. See, the 15 is gone. So I took that off. My tree is getting smaller. Now when I look at this is 15. That's the parent's node. That's 20. Well, I would have to swap these two because I can't, it doesn't meet the max heap definition. So then this is going to be 20. That's going to be 15. This is 9. And this is 7. So if you look at this heap, which is called the heap tree, and the parent's node is greater than the left or right child. Now I'm going to take the root. I'm going to print 20, and I'm going to take the bottom right node, I'm going to move it up there. So I'm going to put 9 here, 15, and 7. Okay. So now this is my heap, but it doesn't meet the max heap tree. So I have to do a process called reheapification. Reheapification says I got to make the root the greater, so I'm going to swap these two together. I'm going to swap the root node, so I'm going to put 15 here, and that's going to be 9, and that's a 7. So this makes it a max heap. That means the root node or the parent node is greater. As far as the left or right children, the order doesn't matter. I could put 7 here and 9 there, it doesn't matter, it depends how it was built. So now I'm going to take 15 out. So when I take 15 out, I'm going to move the 7 up here, and that's a 9. Well, this does not meet the heap, the max heap structure. So I'm going to have to swap these two. So when I put 9 and I put 7 here, now I can take 9 out, write it out. Now, so if I write it out now, all I have now is 7. 7 is the parent node, but there are no children, so I'm just going to write 7. So now this is the result of the sorting. So I have 30, 20, 15, 9, and 7. So I can sort in ascending or descending order, which should not make a difference. This is a very powerful sort. Like I mentioned earlier, it uses the heap tree. I could have done this the same way, either using max or min heap, where if it's a min heap, I will just have the roots to be the smaller than the two pairs. Thank you for your time, and this is the end of the heap sort.